Greetings, fellow hackers. Hello, my name is Ryan, and I'm a developer with Azure Pi, and I'm here today to demonstrate my Mystery Box Challenge project that I'm sure many of you will find very useful. Due to the ongoing pandemic, we have all had to make adjustments to our everyday lives, and most of us are now confined to our homes to avoid spreading COVID, and this includes the need to work from home. And because of this, we frequently find ourselves having to tune out the world around us while we attend important meetings remotely using Teams, or find solutions to the complex problems we encounter every day, and even working late hours to try to meet a project deadline. But this could leave an ignored danger lurking in the house. No, it's not this, it's not that, or even this. It's our furry, four-legged best friend who's lacking opposable thumbs that would allow them to let themselves outside when nature calls. And when nature does come calling, and we're too focused on our work, well, accidents are gonna happen.
Oh, Ludo! Ludo! Oh, Ludo! What? It's a candy bar.
But what if there was a better way and you could give man's best friend a voice so they could notify or even call us when they need to go outside? This is why I've come up with the PDPOTF, or the Please Don't Poop on the Floor. This simple device is powered by a Raspberry Pi and Azure Cognitive Services, so you can be notified on your phone, your computer, or personal assistant whenever your pet approaches the door to go outside. Now, I know what you're thinking. Shut up and take my money. But no, instead of collecting billions of dollars from pet owners, I've decided I'm going to show you how you can build your own PDPOTF in about 10 minutes using the contents of what came in the mystery box. The core part of the device is a Wi-Fi enabled Raspberry Pi such as the Pi Zero W, the Raspberry Pi camera, and an SD card, all of which were included in the mystery box. Other essential components would be a good 5-volt power supply, a method to connect a keyboard to the Pi, such as a USB OTG adapter, an HDMI cable to connect it to a monitor, and there are some other optional items including a nice case or this phone stress ball thing that it'll come in handy a little later. But first, we need to get our Pi set up and running. To do this, we'll have to go to our computer and visit raspberrypi.org/download and download the Pi Manager. Once that is downloaded and installed, run the Pi Imager. Click the Choose OS button, select the top Raspberry Pi OS option, then insert the SD card you'll be using for the Raspberry Pi into your computer and press the Choose SD card button carefully and select the SD card you'll be using from the list. Then press the right button. After a few minutes, the OS will be written to the SD card and you'll be ready to boot the Pi for the first time. To do this, insert the SD card into the Pi, connect the HDMI cable, connect the keyboard. In this case, I'm using a USB OTG hub that was included in the mystery box, but there are other options available, and connect the USB power cable. The first boot of the Pi may take a while and may have a couple reboots during the process. But eventually, you'll get into the window manager and be presented with the setup options. Now you'll need to select your keyboard layout and region, set the super user password, in this case admin works, and select your Wi-Fi network. The rest of the setup can technically be skipped, or you can complete it if you like. It's not that important for this particular demo. Once completed, click on the preferences and go to the Raspberry config. Go to interface options and enable the camera. The next part is optional, but go into the boot options and select CLI if you don't like how slow the window manager is running. Now it's time to reboot your Raspberry Pi with these new configuration settings. While the Pi is rebooting, we can start to set up the Azure Cognitive Services. To do this, log into your Azure portal. In the search box at the top, search for Cognitive Services. Select Cognitive Services from the results. Once that loads, on the Services view, click the Add button, and this will bring up the marketplace. Search for Custom Vision, and then select Custom Vision by Microsoft. Press the Create button. Select a subscription and a resource group, or create a new one. Enter a unique name for your project. In this case, I'll be using my alias RYRIFE-PDPOTF. The name needs to be globally unique. For both the training and prediction resources, select East US 2 and select the free F0 pricing tier. Click Review and Create. After a few minutes, you should be able to go back to Cognitive Services portal and select your training resource. In my case, it was my alias-PDPOTF. When you click on the training resource, that'll bring you up to the settings. Make sure you've selected Quick Start, which is the default, and choose the Custom Vision Portal option. This will take you out of the Azure portal and go into the Custom Vision portal, where you'll need to log in again using your Azure credentials. Don't worry if something goes wrong. If you need to, just sign back out and sign back in. Click New Project and create a new project called PDPOTF and select the resource you created on the Azure portal. In my case, it was my alias-PDPOTF. Select Object Detection and General for the domain, and then click Create. After a few seconds, your project should load. However, if something goes wrong, just go back to the dashboard and try again. If you're not already in the project, click on it from the dashboard. The portal project has three main tabs: Trained Images, Performance, and Predictions. Click on Trained Images if it isn't already, and this is where you'll need to upload at least 15 to 20 photos of our pets. Ideally, these photos would be from different angles and in different lighting conditions, and should roughly be in the same perspective that we'll be mounting the camera in later. I've already taken about 20 photos, so I'll just upload them now. Once your photos are uploaded, you'll need to go in and tag the location of the pet with the pet's name. If there's more than one pet in the photo, you'll need to tag each pet with a different name. The portal is pretty good at detecting objects, but you may need to draw your own bounding boxes around your pet. Don't worry, the box doesn't need to be perfect, and you'll need to do this for each of your photos. Once that is complete, click the big green Train button at the top of the portal. Select Quick Training. The training process will take several minutes to complete, and while we wait on this, we can head over to Twilio.com and register for a new account and phone number. When registering for a new account, you can use a trial account if you like. I've already done this, but once you get your account set up and verified, you can go in and request a new phone number. Once that is complete, go to your dashboard and take note of the account SID and the credential auth token. By now, the Azure training model should be completed, and we can go back to the Custom Vision portal and publish our model for use. In the portal, click the Performance tab at the top of the page. You should see something called Iteration 1. Select that if it's not already. Click the Publish button at the top of the screen. Give it a model name, PDPOTF Works, and select the Azure resource to connect it to, and click Publish. Now click the Prediction URL button at the top of the dashboard and make note of the prediction key and the domain in the image URL. Now we're ready to go back to the Raspberry Pi and write the code that'll actually interact with these services. Once the Pi is fully booted up, we can now start writing our application. We'll be using a handful of lines of Python to make all this code work, but first we'll need to install a few Python packages to connect to Azure and Twilio. First, we'll install the Twilio SDK by running pip install Twilio. Once that is complete, we'll install the Azure Cognitive Services SDK with pip install azure.cognitiveservices.vision.customvision. Once that is complete, you should still be in your home directory. So now you can just type nano capture.py and start the nano editor. You could use BIM or whatever you're comfortable with as well. For a few libraries. The first one will be the Pi Camera library. So you'll type import Pi Camera. The next, we'll need a small utility library to add a delay that will give us time for the camera to start up before we start capturing pixels from it. To do this, you'll type from time import sleep. The next libraries we'll have to import will be from the Custom Vision SDK. To do this, you'll simply follow along and type from Azure.Cognitive Services .vision .custom vision .prediction import custom vision prediction client. And you'll do a similar thing, but you'll import the custom vision prediction client configuration. An additional library that we'll have to install will be the API key credentials library, which is also included as part of the Azure Cognitive Services SDK. So you'll type from msrest.authentication import API key credentials. Next, we'll import the Twilio SDK. You'll do this by typing from twilio.rest import client. The next part of our application is some basic configuration. Remember all the API keys from Twilio and Azure Cognitive Services that we're supposed to make note of? We'll actually have to import them here now. Next, we're going to set up our Pi camera. The actual resolution that you end up using isn't super important, but I have found that 640 by 480 seems to work well. At this point, we're going to write our script in a way that it'll run forever and continuously take photos every 10 seconds and transmit them to Azure Cognitive Services to get a prediction. The camera works by starting a preview window with Start Preview. We then have to implement a small delay to allow the preview window to fully render. 1 or 2 seconds is sufficient. And now we have to capture an image from the camera preview. You do this with camera.capture, store the image somewhere, such as capture.jpg. And then you can stop the preview to close the preview window out. We now need to transmit the image over to Azure to get an accurate prediction. To do this, we first need to enter our prediction credentials using the API key credentials library. And we have to create an instance of the predictor. Now we can actually transmit our image over to Azure and get the results back. Once we get the results back, we can actually loop through each result and check the probability for a match for our given tags. And remember, the tag is what's matched to our pet's name. Python has a nice command called set, which will generate a unique list of each pet that was located. For the probability, I've set it to 70%. But you may have to adjust this value based on the images that you've uploaded for your pet. If the probability exceeds 70%, we're going to add the tag from the prediction to our pets collection. Next, we're going to see if we found any matches greater than 70%. And if we do, we're going to transmit a message to the Twilio client telling us to send us a text message to our phone number. Once we've sent the Twilio message, we're going to wait about 10 seconds before checking again, using the sleep command. And that's pretty much it. We can now press Ctrl X, save this file, and we're done. To have the Python script run as soon as the Raspberry Pi is powered on, you need to go to the command line and type nano/home/pi/.bashrc. This will load the bash resource file. Scroll to the very bottom and type python/home/pi/capture_pi. This will tell bash to launch our capture Python script as soon as it boots up. Now you're ready to connect the camera to the Raspberry Pi. To do this, first disconnect the power from the Raspberry Pi, and then take the Raspberry Pi camera module and the included ribbon cable and connect all the components. Be careful, the ribbon cable is very fragile. Congratulations, you've now built your first PDPOTF. You're ready to put it in a case and mount it to the wall. You'll want to mount your PDPOTF near a door at an appropriate angle to actually capture an image of your pets. To do this, use the stress squishy thing that's conveniently wedged at about 30 degrees. Stick the camera to the stress ball and stick both of them to the wall. You may need to use some tape to actually get it to adhere, but don't worry, just stick it and forget it. Now when you plug in your PDPOTF, within a few minutes, anytime your pet walks into the field of view, you'll start receiving text messages directly to your phone. Well, there it is. I hope you've all had as much fun watching this video as I did creating it. If you have any questions, feel free to reach out to me. And until next time, see you later.